Hello learners and welcome to a Natural Sciences lesson. So in this lesson we're going to be answering practice questions and application questions that are based on a parallel circuit. So to begin with our first practice question that is based on a parallel circuit, we are told that a battery consists of 3 cells, that each of those cells they have 1,5 V, the voltage of each of those cells is 1,5 volts, and they are connected in parallel. And we are then supposed to describe how the cells are connected to each other. Remember, they are connected in parallel. How are they connected to each other? If they are connected in parallel, the negative terminal will be connected to another negative terminal. Whereas the positive terminal will be connected to another positive terminal. So, in a parallel connection, all the negative terminals are going to be connected together, and all the positive terminals are also going to be connected together. Hence, we're saying that a negative to a negative and a positive to a positive, that's only if those cells are connected in parallel. Then we now need to draw a representation of these 3 cells that you're saying are connected in parallel as they would be shown in a circuit diagram. So now, because we're saying that negative to negative, positive to positive, how does that look like? So, when you have a diagram like this, let's just draw it nicely. Let's do it this. A negative with a positive terminal, another negative terminal with a positive terminal, a negative terminal with a positive terminal. So each of these, they are all going to be connected together, and each of these are also going to be connected together. Now, all of these negative terminals, remember, they must still be connected to the positive terminals outside. So the negative is going to be connected to a negative, and this negative to another negative, right? And then with regards to the positive is connected to a positive, and the positive again to another positive. However, all 3 of these negative terminals will be connected to all 3 of these positive terminals through a wire, or using just one wire. So that means all of these 3 negative terminals are just basically making up one negative terminal, and all of these 3 positive terminals are making up one positive terminal. Then the sum of all the negatives is going to be connected to the sum of all the positives terminals, and hence why we're saying that they are all going to be negative to negative, positive to positive, and however, overall, they will still be connected to each other. Because if we are just going to leave them as negative and negative, there won't be any current flow in this particular circuit. So overall, they would still be connected to the positive terminal, even though they start off by negative to negative and positive to positive, they will still be connected at the end. Now, question C is asking us now, what is the total potential difference of the 3 cells? Now, what we need to remember is that we have said all the 3 negative terminals will each make up one negative terminal, and all the positive terminal will each make up one positive terminal. That means, in essence, in overall, we only just have one cell in that particular circuit. So all of those 3 cells connected, they are going to be connected in such a way as if now we only have just one cell connected. So that then means the total potential difference is going to be equal to the 1,5 volts. So So it's going to be equals to the 1,5 volts, because all of those negatives, they are going to sum up to just one negative, and all the positives will just sum up to one positive. And remember, each cell has 1,5 volts. So if all three are summing up to just one cell, that means that battery will, or those three cells will have the total potential difference of 1,5 volts. Then question D is asking us now the advantage and also now the disadvantage of connecting cells in parallel. So starting with the advantage. The reason why we are connecting cells in parallel is because, or the advantage why we would connect cells in parallel would be when one cell breaks, the others would still supply the same amount of energy. So when one cell breaks, that means when one cell runs flat, all the other batteries or all the other cells will still supply the very same amount of energy as if none of the cell is flat. So if you're connecting your cells in parallel, they each are going to work together to supply the same amount of energy as if none of the cells is flat or none of them are not working in that particular circuit diagram. So that's basically one of the advantages that is used when we are connecting our cells in parallel. Then number two, the disadvantage. So the disadvantage of connecting cells in parallel, they take longer to charge. So they take longer to charge. Whenever we are connecting our cells in parallel, and let's say now all of them, they are flat, they are going to take a long period of time for them to charge because they are going to, and also another advantage, you would say, they last longer. So when they are connected in parallel and you want to charge them, they're going to take a longer period of time for them to become fully charged because they were connected in parallel. So that's now our disadvantage and also our advantage of connecting the cells in parallel. So now moving on to the next part of the questions where we're supposed to complete the statements. And the first statement says, if you add more resistors in parallel or in a parallel circuit, what happens to the current or the voltage? So we need to remember that when we are adding more resistors in a parallel circuit, we are actually decreasing the total resistance of the circuit. And once the resistance of the circuit decreases, that means the current strength is going to be increased. So therefore, the answer here is going to be A, the current will increase, because the current will not decrease when we are decreasing the resistance, and the voltage in a parallel circuit will remain the same throughout any point that you're trying to measure it from. So therefore, the answer is A. Second question, the electric current is measured in, is it either amperes, watts, meters, and centimeters? Now we need to remember that these two, the last two, meters and centimeters, those are the measures of lengths, not current. And then watts is the measure of power. So power is measured in watts. And then we should know that our current is always measured in amperes. So electric current is measured in amperes. Now, with all of that said, before moving on to the next part of the questions, being the application questions that are also still based on the parallel circuit, we're just going to go for a quick short break, and I will see you just after this.